Okay, so for our last one, we're going to do the worksheet example number 6. Try my best to make sure you can actually see everything. And let's talk this through. A jet plane lands with a speed of 100 meters per second and can accelerate at a maximum rate of -5 meters per second squared. So that means it's slowing down. And it's going to come to rest. So we know its final velocity will be 0. What the column in the left side of your paper is for doing what I've been doing on my blank pieces of paper. It's for you to kind of build what you know. So we know V naught is 100 meters per second. We know acceleration is -5 meters per second. V final we know will be 0. It's at rest. The first part asks us, from the instant it touches down, what is the minimum time needed? So time, that's what we're solving for. That's supposed to be a question mark. But we also actually know x naught, because we're going to set our origin, through my handy-dandy picture here, at x naught equals 0. And we know our v naught is 100 meters per second. So at x equals 0, v naught is 100 meters per second. My acceleration is this vector here, going in this direction. It's -5 meters per second squared, so it's slowing down. And we know at this final x final, v naught, or v final will be 0. But we don't know what this distance is. And we don't know what the time is that it takes to get there. So if we look at our equations, if we have our v naught and v final and acceleration, can we solve for time? And when you look closely at them, you will see, there you go. I have the second one down has final velocity, initial velocity, acceleration, and time. So I have every piece but time, and that's what I want to solve for. So let's start by solving for time. V naught plus AT. Subtract my V naught, subtract my V naught, I get V minus V naught equals AT. I want to solve for that, guys, so I'm going to divide by A, and my new equation, so I don't run out of space, is V final minus V initial divided by acceleration equals time. Now I can plug my numbers in. So my V final is 0 minus, oops, we'll just leave that out, minus V initial, which is 100 meters per second, so that becomes a negative. Divided by acceleration, -5 0.00 meters per second squared equals our time. So this is a happy thing. The negatives cancel out and become positive. 5 into 100 is 20 meters. I'm sorry, meters cancel out, and we are in just time. 20 seconds it takes is t. So let's double check our units over on this side. I am meters per second. Can we see? Meters per second divided by meters per second squared. This goes to meters per second times seconds squared over meters, taking the inverse from this. This seconds cancel us out with that one. Meters cancel out, and I'm in time. Good. So that's our final answer. So now we know equals 20 seconds. Cool. Part B says, can this plane land on a small tropical airport runway that's 800 meters long? So the way I look at this is, let's see what happens at 20 seconds. What's my distance that I've covered? Because if my distance I've covered is less than 800 meters long, then yes, it can. So what do we have here? Remember, our x naught is 0, so we don't have to worry about that. We have that piece. We have a test time. we have acceleration time, and we want to know if it'll do all that and be less than 800. So let's see. So x equals, x naught is 0. We're going to leave that out. V naught t plus, you can see that, plus 1/2 a t squared. I have that. I have time. I have my acceleration time. So this will give me what distance I am after 20 seconds, or at 20 seconds. So what do you think? Is it going to stop in time? I don't know. I don't know. So we have 100 meters per second times time, 20 seconds. Seconds are going to cancel out, so that gives me a distance. Plus 1/2. My acceleration is negative 5.00 meters per second squared times my time of 20 seconds. And that's going to be squared. So let's do this one step on our calculator. We can actually see it. I have parenthesis 100 times 20 close parenthesis. They're both positive quantities. Plus parentheses. Again, I'm going to do the 0.5, or change the 1/2 to the 0.5 just because that makes me happier. Times negative 5. Okay, we're good. Negative 5. For me, I have a negative symbol here. I prefer not to use it and just put it in after. Times 5. Actually, we need to. So we'll come back here. I'm going to use my backspace. I'm going to make this a subtraction because that negative 5 is going to make this whole piece negative. So times 5 times 20, that little up arrow, squared. Close my parentheses and hit enter. And something went way wrong. Oh, because I raised it to the 20th. So my power was a little bit off. Now let's try that. Hit enter. So that equals 1,000 meters. So the answer to B would be no. It needs a lot more runway than 800 meters. Okay, so that's that. If you have any questions, work on a couple of the other examples in your worksheets, and we will see you on Tuesday.